morning, everybody. So today we'll finish the remaining part of the syllabus of your panel data econometrics. And by considering the given critical situation we are passing through because of the pandemic, I have reduced your syllabus, particularly the part of panel data, as well as the time series part, because you are familiar with the classroom teaching and you can easily understand a subject like econometrics, which is highly technical, is difficult to understand in online mode. So for that reason, for this year, I have decided to reduce your syllabus as well as the mode of presentations, because to understand clearly, we need a lot of derivations, we need a lot of explanations of the different steps, which is not properly possible on the online mode. For that reason, particularly in this year, for panel data as well as for time series, I shall try to provide you the basic conceptual steps involved in some parts of panel data, in some parts of the time series. Okay, and the detailed derivation of the parts we have covered in the online course. You can go through the standard textbooks I have referred in the last class, the book for Baltagi or Green, or you can also go through my book for the detailing part of the derivations, because I particularly realize that you may face some problem to understand the steps we have followed on the online mode, because there is a little scope to provide you a detailed derivation needed to understand the inner meaning of the term, inner meaning of the coefficients, inner meaning of the equations we are using. So for that reasons, I request you to go through the book, only those part of the books which are covered in the class. Okay, so let me start with the portion we have finished in the last class. So in the last class, we have defined the basic concepts of the panel data, the basic benefits of the use of panel data, and the basic structure of the panel data. So for the remaining part, as you go through the syllabus I have mentioned, the remaining part is on the panel data econometric models. So the topic for discussion today relates to the different econometric models with panel data. So before going into detail in the models, let we start with the structure we have provided in the last class. So to understand the different steps, you have to keep in mind this basic structure of the data matrix, because it will help you to understand what we are trying to do. So in the data matrix, we have several rows, several columns. Each row represents a cross section for a particular time period. Each column represents a time series for a particular cross sections. And by taking all together, we have a panel data. And based on this data matrix, so you have to keep in mind this data matrix is only for a single variable X. Similarly, you can construct this kind of data matrix for other variables X1, X2, X3, etc. So in all cases, the basic structure of panel data for a particular variable looks like this. And on the basis of that, we have mentioned in the last class, we can construct three types of mean value. One relating to the within group mean. Within group mean value indicates you the average value of a particular variable for a particular cross-section unit over time. So we are taking sum of the variable over time for a particular cross-section unit xi to get the within group mean. Similarly, between group mean, we are taking the sum across the cross-section unit at a particular time point t. And if we allow to change both the dimensions, cross-section as well as the time series, we have the overall mean. So if we have a panel data, we can calculate three types of mean value. One is the within group mean value, between group mean value, as well as the overall mean value. Similarly, we can also calculate variance and covariance of different types if we have a panel data. So as we have three types of mean value, similarly, we can calculate three types of variance and covariance with panel data. So we start from here today. With the background, we have some knowledge about the different types of mean value we can construct it on the basis of the given panel data. So as we have calculated within group mean, by using within group mean x bar I dot, we can calculate within group variance. So you know the formula for variance. So this is the sum of square which is used in calculating a variance. And you are familiar with the symbol S, capital S, suffix XX, like XY, etc. We have used this kind of symbol earlier in our multiple linear regression model. So we are using the similar kind of symbols to understand the different issues of panel data. So let we start with the within group variance. So in your data, you have n cross-section units. So you have n groups. So for a particular group I or a particular cross-section unit I, you have information for several years. So by utilizing the information for several years for a particular unit I, we can calculate the sum of square of that variable by taking sum over time for a particular unit I. And we can use this sum to calculate the variance measure of the variable x. So by using this sum of square, you can calculate the variance of x for a particular cross-section unit I, simply dividing this sum by capital D, because we are taking sum over time. So this is the variance of x for a particular cross-section unit I. Think about the data matrix we have. So this result relates to a particular column, because particular column provides you information for a particular cross-section unit. So you can get this estimation for a particular column. So if we take all the cross-section units we have in a sample, we can calculate the within group sum of squares for that variable x. So how do we get the within group sum of squares for all the cross-section units? So this is the formula for a particular cross-section unit I. So if we take again sum over I, so here we have taken sum over t only, not over I. So if we take again the sum over I, we can get the within group variance estimates for all cross-section units in the sample we have. So let we denote it by the symbol S, capital S, XX, W. W denotes within group. XX denotes, you are familiar with, we are taking X twice to take mean deviation of X whole square. So one X, X minus X bar, another X denotes X minus X bar. So XX means the square component. So sum of square of X, W denotes we are taking the deviation from the within group mean. So XIT is your variable in a panel data framework. In a panel data, we have suffix IT. I denotes cross-section unit. T denotes the time series. So XIT denotes a particular cell in the data matrix we have. So if we take a deviation xit minus xi bar dot, xi bar dot, you have the mean for a particular cross section unit I. So if you take deviation this kind of mean value from the actual observation point, and we take sum twice, one across the cross section unit, another across the over the time, we get what is known as sum of square of x within the cross section units in your sample. So within sum of square, we have to keep in mind is obtained in this way. Similarly, we can calculate the covariance as well. For a variance component, we need the same variable x twice. For a covariance, you need at least two variables. So suppose we have two variables x and y. So as we have constructed a data matrix for x, we can also construct a data matrix for y in a similar way. So the covariance for a particular cross section unit I, we need the deviation of x from x bar I. Similarly, the deviation of y from y bar I, and you have to take the sum of this cross product over time. So this sum over time, this also relates to a particular column in your sample, because a particular column provides you a particular cross section units. So this formulation SXYWI provides you the covariance measure between x and y for a particular cross section unit I, where we are using the mean value within group mean value. That's why this measure provides you the within group covariance of xy for a particular cross section unit I. Similarly, if we take all cross section units together, we can get the within group measure of the covariance is XYW. So you have to take sum again across I. So at this stage, to find out the covariance term for a particular cross section unit, we have taken sum over time, and to consider all cross section units again, so you have to take the sum of this sum of the cross product across the cross section unit. So I varies from 1 to n. So ultimately, you have to take double sum of the cross product xit minus x bar I dot into yit minus y bar I dot to get the covariance measure, where we have taken within group mean value. So in this way, we can calculate within group covariance. So you are familiar with the basic formula for covariance. For single dimension, you have sum of xi minus x bar into yi minus y bar. So as we have a double dimensional variation, one dimension variation across I, another dimension variation over time. So we have to take sum twice, one across the cross section unit, then over time, and x also varies in a two-dimensional way, one across I, and then over time t. For that reason, to calculate covariance in a panel data model, we have to take double sum if we want to consider the full sample. But for a single cross section unit, we can get this kind of formulation, or so here we allow to change the measurement of covariance across each cross section unit. Similarly, you can also allow to change this kind of measure over time. So in that case, you can calculate a particular covariance term by using a particular row. Here, the formulation we have shown in this slide, we have taken a particular column to calculate this covariance. Similarly, if we use a particular row, we can get a covariance for a specific time period. So as we have get the covariance for a particular cross-section unit, similarly, we can also calculate the covariance at a particular time point by taking at the first hand the variation across the all cross-section units. So ultimately, to get, you have to get the double sum. Either you want to take x bar I dot, or if you want to take x bar dot t, whatever may be. So in this way, we can get within group covariance. This is the formula for within group variance. This is not exactly variance. You have to divide here by the number of observations. So how many observations we have in this formulation? In this formulation, we have the number of variation t, capital T, because we have taken sum over time. So to get the variance of x for a particular cross-section unit I, you have to divide this sum by capital T only. But to get the variance component for all cross-section units together, or if we use this formula, you have to divide this sum of square by n into t, because you have taken n as well as t. So number of observations in this formulation is equal to n into t. Therefore, to get the within group variation of x, you have to divide this sum by n into t. Similarly, for covariance, this is the covariance between x and y for a cross-section unit I. So to get the covariance measure, you have to divide this sum by capital T only, because you have taken sum over a particular column. Okay. And to take the all cross-section units, we are taking sum of the covariance measure for the cross-section unit I. So you have to take sum of this element. So by taking sum of this element is equivalent to taking sum of this element twice. So that's why we ultimately have to take sum of xit minus x bar I dot into yit minus y bar I dot to get the covariance component for the sample as a whole. Okay. So you can calculate independently along with me by your in your exercise book how to get this kind of formulation from this. In a similar way, as also we have between group mean. So we can calculate between group variation or between group variance. So by using within group mean, we have calculated within group variance, within group covariance. Similarly, by using between group mean, we can calculate between group variance. So this is the formula for between group variance of x. Now look at closely this formulation. Here also we have taken double sum. One, sum over I, second, sum over t. But if you look at the variables we are using here, xi bar dot minus x bar. What is x bar I dot? X bar I dot is a within group mean value. So this mean value varies across the cross-section unit. So you have different x bar for different cross-section units. So if we have n number of cross-section units, so we have n number of mean value here. And x bar is the overall mean or the total mean. So if you take a deviation, x bar I dot bar minus x bar and take whole square and take double sum, you will get between group variance. Okay, now as in this variable, there is no time component, that is, this variable is time independent. There is no time suffix here. You have a suffix only I. So this whole square component will be the same for all time period. So to capture this measure for all time period, so in other words, the sum over time, you will get the same value of xi bar minus x bar for every time. So for that reason, ultimately you have capital T into sum of x bar I dot minus x bar whole square. Why do we get capital T? Because over time, this measure is a constant. So if we take a sum of a constant value, so it will be equal to the number of that value. So how many xi bar into x bar appears in your sample? T times. For that reason, we have multiplied this sum by t, because this sum of square appears t times, and this sum of square is time invariant. That is, this sum of square is the same for all time period. Okay, that's why we have multiply this expression by t to consider the sum over time, and ultimately we have to take sum only across the cross section unit I, because the mean value varies across I. So how do we get this mean value? Think about our data matrix and go through the last row of the data matrix. In the last row, we have calculated mean value for the different cross section units, and we have denoted the measure by x bar I dot. So this x bar I dot is obtained by taking the mean values for several cross section units. Similarly, we can calculate the between group covariance. So how to get between group variance or between group covariance? In that case, your variable will be the within group mean value, and this mean value will vary across the cross section unit. So x bar I dot, and you have to take a deviation from the overall mean x bar. So to calculate between group variance or between group covariance, just look into closely the formula. We have to take the deviation x bar from x bar I dot. So by taking the deviation x bar from x bar I dot, we can get between group version of the variance and covariance. How to get within group version of the variance or covariance? To get within group version, we have to take deviation within group mean x bar I dot from the original value xit, or the observation point at any cell in the data matrix. So if we take the deviation of within group mean value from the particular data point, you get within group version of the covariance, within group version of the variance. So try to understand the meaning of this term within group variance. In that case, we have to take deviation within group mean from the data point xit. Similarly for the covariance. But when we calculate between group variance and between group covariance, we have to take deviation of overall mean from the within group mean. So here we have to take deviation within group mean from the actual observation xit. And to calculate between group variance, we have to take the deviation of the overall mean from the within group mean value. And for variance, you have to take the square of the same variable, and for covariance, you have to take the cross product of the two variables x and y. Okay, so this is another kind of variance and covariance we can calculate if we have a panel data. The third type of variance and covariance can be calculated from the panel data, are called the total variation and total covariance. So total variance and total covariance can be calculated by taking deviation of the total mean or overall mean x bar from the actual data point xit. So if we take a deviation overall mean from the actual observation point xit, and of course we have to take sum in both dimension, one across the cross section unit, another one over time, to get the variance of x. And here we are considering overall variation, that is the how actual data point deviates from the overall mean value. Okay. Similarly, the covariance part of the total mean value we can calculate in this way. So just to try to remember three types of variance, how to get. In the case of within group variance, you have to take within group mean value. You have to consider within group mean value, and you have to take a deviation from the actual data point. So to calculate, so we have 10 minutes for this session, and then we have to start a new session to continue further. So for within group mean value, we have to take, within group variance, we have to take deviation of within group mean value from the actual data point and take the square for variance and take the cross product for covariance. For between group measure, you have to take a deviation of the overall mean from the within group mean value and take square term to get a variance component and take cross product to get a covariance component. For overall variance, you have to take overall mean and you have to take the deviation of overall mean from the actual data point xit and to take square term to get the overall variance, and you have to take cross product to calculate the covariance for the overall mean value. So these are the three types of variance and covariance we can calculate if we have a panel data. Now the question is why we are discussing about three types of mean values, three types of mean values, three types of variance, three types of covariance. Because if you try to remember the basic formula for regression coefficient, because ultimately we use this data to estimate a regression model. It may be a simple linear regression model, it may be a multiple linear regression model, but our ultimate objective is to estimate a model with this data. So how to get an estimate? You are familiar with the classic formula for beta hat for a simple linear regression model. Beta hat is equal to sum of xy divided by sum of xi square. So what is sum of xy? Sum of xy indicates the covariance between x and y in a cross section. Similarly, sum of x square indicates the variance of x in a cross section framework. So in a simple linear regression model, to get beta hat, we need covariance between x and y as well as the variance of x. Okay, in a multiple linear regression framework also you will get the similar result, but the expression will be somehow complicated, not simple like a simple linear regression model. But in that case also beta 1 hat, beta 2 hat, beta 3 hat, what we have got in the case of multiple linear regression model, in that case also you can find that we need two measures to get beta 1 hat. One is a covariance measure, another one is a variance measure. So to get OLS estimates or to get the maximum likelihood estimate, whatever may be, to get the regression coefficient, we need covariance measure as well as the variance measure. For that reason, we are concentrating on different types of covariance measure, different types of variance measure. If we have a panel data, if you have a cross-section data, you have only one type of variance, only one type of covariance, and ultimately you have only one type of regression estimate. If you have a time series data, in that case also, you have one type of variance, one type of covariance, and ultimately you have one type of regression coefficient. But if you have a panel data, you have three types of mean value. You can calculate three types of variance. You can calculate three types of covariance. And accordingly, you may have three types of regression coefficients if you have a panel data. Okay, one regression coefficient may relate to the variance, covariance of within group mean. One kind of estimate may relate to the variance, covariance of between group mean. Another kind of regression coefficient may be related to the variance, covariance of the total variation, overall variation. Okay, so these three kind of estimates we can have if we have a panel data. Now, in these three types of variance or covariance, we can prove that Sxxt is equal to Sxxw plus Sxxb. What does it mean? Xx denotes the variance measure. So the variance by taking overall mean, in other words, overall variance is equal to within group variance plus between group variance. So we can calculate separately total variance. We can calculate separately within group variance. We can calculate separately between group variance by following the formula we have mentioned above. But using this formulation, we can easily prove the total variation or total variance is equal to within group variance plus between group variance. Similarly, the total covariance will be equal to within group covariance plus between group covariance. In other words, we can show later on the total estimates in the regression coefficient can be decomposed into the within group estimates as well as the between group estimates. So before going into detail, let us look at how we can prove this statement, that is the total variance is equal to within group variance plus between group variance. For that purpose, let us start with the definition of total variance. So you can try simultaneously along with me. So try to start with this formula. Sxxt, we have defined Sxxt is equal to double sum of xit minus x bar whole square. So S denotes simple sum of square. You have to keep in mind. So Sxxt is equal to double sum xit minus x bar whole square. Now in this formulation, just take a simple manipulation. That is, how do we get this step? Just by taking a minus x bar I dot plus x bar I dot. Okay, so we have introduced minus x bar I dot plus x bar I dot in this formulation to get this step. Now expand this whole square by taking this xit minus x bar I dot as A, x bar I dot minus x bar as B. So it will be A plus B whole square. So if we expand this whole square part, so this is A square plus B square plus twice AB component. Okay. This part, that is A square, this part, if we look at the formula, this part provides you the within group variance of X, because we are taking deviation of within group mean from the actual data point xit. So this part will be equivalent to Sxxw. Similarly, this part will be equivalent to Sxxb, between group variance, and the remaining part twice AB component. Now we can easily prove that this twice AB component will be equal to 0. So to find this result at the first hand, just multiply this part xit minus x bar I dot xit minus x bar. So you will get this, and to get this part from this, so here you have sum twice, one from I is equal to 1 to n, then I is equal to 1 to t. So let we retain this summation part I is equal to 1 to n, but we have taken the sum only over time. So just take a first bracket within this and operate the sum over time first. So if we take a sum of xit, so sum of xit, think about sum of xit, sum over t is equal to 1 to t. Okay, so it will be equal to capital T into x bar I dot. So after multiplying it, you will get t into x bar I dot square. Similarly, if we take sum of this component over time, you will get this. So in this way, you will get this component. So if you look at closely, this part will be 0. So ultimately, you will get this plus this. So the total variation is equal to within group variance plus between group variance. So we can stop now for the first session, because we have a few seconds left, and we start afresh in the second session on the basis of these three kind of variance covariance measure. How do we use panel data to estimate different types of regression model? Okay. So I will send you again the link for the next session. So wait for the time being.